We have seen arc phenomena in the last class. Today we will see arc interruption. Okay. So we know when arc is struck between the contacts of the circuit breaker, because of that arc, enormous heat is produced. Okay. And because of the enormous heat that is produced across the contacts of the circuit breaker, the circuit breaker contacts may get damaged. Okay, so let us assume these two are the contacts of the circuit breaker. One is the moving contact, another one is the fixed contact. So when current is flowing through these two contacts, if fault occurs, these two contacts which were initially in contact with each other, they will be separated. And we know that even though contacts are separated, there will be discharge of electrons from one contact to another contact. That is due to field emission and due to thermal emission. So that discharge of electrons is nothing but the arc. So this arc actually it passes for very short time, but it is dangerous on account of the energy generated in it is in the form of heat, which may result in explosive force. Okay. So this arc plays a vital role in the behavior of the circuit breaker. So our purpose of using circuit breaker is to make or break the circuit. Okay. So it is operating as a switch actually, but it is also operating as a protective device under fault condition. So if any fault occurs, the circuit breaker has to disconnect the faulty section from the healthy section. But there is a drawback in the circuit breaker. The drawback is that whenever circuit breaker contacts open, due to field emission and due to thermal emission, that is due to potential gradient and the high current density of the electrons which are emitted due to field emission, arc is maintained within the contacts. Arc is struck and it is maintained within the contacts. So this arc will produce enormous heat, so it may cause damage to the circuit breaker contacts as well as it may cause damage to the system to which this circuit breaker is connected. So the purpose of circuit breaker is to protect the system. Instead of protecting, the circuit breaker itself may damage the system because of the arc which is struck between the contacts. Okay, because of the arc which is struck between the contacts means because of the heat produced by this arc, okay, which is struck between the contacts. So this arc must be extinguished as early as possible, otherwise it will damage the circuit breaker as well as the system. So the supply that is given, the circuit breaker can be connected to a DC supply system or an AC supply system. Okay. So if the circuit breaker is connected to a DC supply system, the arc which is struck, we can call it as DC arc. And if it is connected to AC supply system, the arc which is struck between the contacts, you can call it as AC arc. And what the engineers have found is that in order to interrupt the DC arc is more difficult when compared to interrupt the AC arc. So what is meant by interruption? Interrupt means we want to extinguish the arc. So extinguishing the arc or interrupting the arc means same. So why interrupting the arc of AC is easy when compared to DC? The reason behind that is, you know, this is a sine wave, isn't it? This is a sine wave. So we have already seen the arc voltage and arc current in the last class. So this is, let us assume this is the arc current, okay, which is sinusoidal in nature. This arc current, if you see, it has initiated at this instant of time, okay, x-axis is time, okay, and it is its magnitude is gradually raising and it is reaching to its maximum value and its magnitude is gradually reducing. Okay, at this particular instant where you can see a red dot here, at this particular instant what is happening? Current is zero at this particular instant of time. Okay, what about the magnitude of current? It is zero. So and the negative cycle, negative cycle will start from this, from here, and it will again raise to a maximum value. Again, it will become 0 at some other particular instant of time. Okay, and again it will raise and it continues. Okay, so in an AC arc, as the current becomes 0 during the regular wave, arc will vanish and it is prevented from restriking. Okay, so you don't know what's meant by arc vanishes. Okay, so now at this particular instant, okay, current is 0. Okay, that means at that particular instant, arc is not there. Arc current is 0 means arc is not there. Okay, at for a fraction of second. Okay, the arc is not there at this instant. Arc current is 0 means arc has vanished. But again, next cycle next cycle continues. Okay, next half cycle continues in the negative region. Okay, that means the arc has restruck. So for a particular instant of time, arc is extinguishing, again it is re-establishing, okay, or re-striking. Okay, so arc is extinguished at this point of time, but it has restriken. Okay, and at this point of time, arc has extinguished, again it has restriken. Okay, so these points you can call it as natural current 0 points. This red points, what you can see. So naturally in AC supply systems, the current will become 0 at a particular instant of time. So this factor is considered as means for extinguishing the arc. This factor is considered here. Why? Because at the instant when the arc is becoming 0, if you are able to extinguish the arc, if you are able to stop the restriking of the arc, okay, if you are able to stop the restriking of the arc, the second cycle will not continue. Okay, so that's the reason why interrupting the AC arc is easy when compared to interrupting the DC arc. Why? Because in DC arc the magnitude of the current will remain constant. Okay, it will not become 0. Okay, so but in AC the magnitude of current becomes 0 at certain particular instant from one half cycle to other half cycle. So if we are at the weak point, this is the weak point for the arc. So at that particular weak point, if you are able to extinguish the arc, then the arc will not restrike. There are some factors which are responsible for maintaining the arc between the contacts. Okay, so in between the contacts, okay, in between the contacts, when the circuit breaker contacts are open, whenever fault occurs, okay, arc is struck between the contacts. Okay, due to it is initiated due to field emission and maintained due to thermal emission. Okay, there are two factors which are to be considered, which are responsible for maintaining the arc. Okay, one is the potential difference between the contacts. Okay, so one factor which is responsible for maintaining the arc between the contacts. Okay, it is initiated and initially maintained by the field emission and thermal emission, but it is maintained between the contacts because of one of the factor for the maintenance of this arc is potential difference between the contacts. Next one is ionized particles between the contacts. Okay, so because of the ionized particles between the contacts and because of the potential difference between the contacts, arc is maintained. Okay, so the potential drop between the separating contacts is just sufficient to maintain the arc, and of course that the potential difference will be very small. Okay, the potential difference between the contacts will be very small and it will be sufficient to maintain the arc. Okay, now our aim is what? We want to extinguish the arc, we want to interrupt the arc. So in order to extinguish the arc, okay, if the required potential difference which is maintaining the arc between the contacts is not obtained, then arc can be extinguished. Okay, if the potential difference between the contact is inadequate to maintain the arc, then arc can be easily extinguished. Okay, So in order to make the potential difference between these two contacts inadequate to maintain the arc, in general what we can do is we can separate these two contacts, fixed contact and moving contact. And of course moving contact is the one which is moved, fixed contact will not move at all. So the distance between the contacts can be made to such a value that the potential difference becomes inadequate to maintain the arc. But okay, I hope you have understood if you are listening carefully. Okay, so if the distance between these two contacts is increased gradually, then the potential difference between these two contacts can be made inadequate to maintain the arc. So in order to increase the distance between these two contacts, okay, so we have to move this moving contact far away from the fixed contact. Now, if it is a high voltage system, okay, if it is a high voltage system where separation of many meters is required, okay, so if it is a high voltage system where separation of many meters is required, then this method of interrupting the arc by making the potential difference inadequate to maintain the arc is not possible. Okay, so now to move the moving contact many meters away from the fixed contact, to so that potential difference becomes inadequate to maintain the arc, it's not possible. So this method of increasing the distance between the fixed contact and the moving contact to make the potential difference inadequate to maintain the arc is not practicable. Okay, but for low voltages you can do that. Okay, for interrupting low voltages you can do that. Okay, and the conductance of the arc, okay, the arc conductance will be always directly proportional to the electrons per centimeter cube produced by ionization, and it is also directly proportional to the diameter of the arc. Okay, okay, and it is also inversely proportional to the length of the arc. Okay, so the conductance of the arc will be proportional to number of electrons produced by ionization. Okay, so if the number of electrons are reduced, then the conductance of the arc will also reduced. Okay, so if the diameter of the arc is reduced, then also we can say the conductance of the arc is reduced. Okay, and conductance is inversely proportional to the length of the arc. As the length increases, conductance will decrease for the arc. Okay. Now, by increasing the length of the arc, we cannot reduce the conductivity of the arc, but we can reduce the density of free electrons. As per this representation, what I am telling, conductance is inversely proportional to the length of the arc, of course. But by increasing the length of the arc, we cannot reduce the conductivity of the arc, but we can reduce the density of free electrons. Okay, so if the density of free electrons is reduced, then this will reduce the ionization and it will decrease the diameter of the arc. Okay, when the number of ions, means the number of electrons, the density of the electrons is reduced, okay, then we can, means when less number of free electrons are there, we can deionize those electrons to interrupt the arc. Okay, so how so it is similar to, so in order to increase the density, in order to reduce the density, sorry, in order to reduce the density, you can take an example. So I think once I have already discussed about this elaster in your offline class. So if you see here, some person is holding an elaster with his hand and he has expanded the elaster. Okay, so let us assume this elaster is nothing but our arc. Okay, so you can see the cross section of this arc here. Okay, this elaster is nothing but our arc. You can see the cross section of the arc here. The density of the elaster is much more when the person is holding it with his hand. Now the person has expanded it. Okay, so when the person has expanded the elaster, okay, means when the length of the arc has increased, okay, the density of electrons have reduced here. Okay, so when the density of the electrons have reduced, definitely the diameter of the arc will reduce according to this second figure. Okay, so when the density of electrons have reduced, the diameter of the arc is reduced. So when the diameter of the arc is reduced, the number of electrons across the cross section have reduced here. So simply by deionizing by some method, okay, so we can interrupt the arc. Okay, we can easily interrupt the arc by deionizing by some method. Okay, so when more number of electrons were there, okay, across the cross section of this arc, okay, if more number of electrons were there, we need in order to deionize the electrons or deionize the arc, we need more energy. Okay, more whatever energy, by whatever means by which we want to extinguish the arc, that has to be increased. Okay, what are all the different methods by which we can extinguish the arc, I will discuss. Okay, next. Okay, so by whatever means we want to deionize the arc, that means has to be increased. Okay, its magnitude must be more. Okay, its quantity must be more. Okay, but when less number of electrons are there along the arc, when in the cross section of the arc, then deionization becomes very easy. Okay, so deionizing the arc path may be achieved, okay, by cooling the arc, okay, by allowing cool air to pass through the arc. Okay, the cool air will take away the heat of the arc, or by bodily removing the ionized particles from the space between the circuit breaker contacts. Okay, by some means you can easily remove the ionized particles. Okay, because they have less density. Okay, so in two ways you can easily deionize the arc path. One is by cooling the arc or by bodily removing the ionized particles. Okay, I hope you have understood. Okay, so let us discuss the arc interruption methods. Okay, so there are two methods of arc interruption in the circuit breakers. So one is high resistance method, another one is low resistance or current zero interruption method. Okay, so by using two methods you can interrupt the arc. Okay, so let us see this high resistance method. So in this high resistance method, arc resistance is increased, okay, with the time. Okay, so as the time varies, the resistance of the arc is gradually increased so that current is reduced. We already know resistance opposes the flow of current. Okay, so in this high resistance method, arc resistance is gradually increased with the time so that current is reduced to such a value that heat produced by it is not sufficient to maintain the arc. Okay, so the current magnitude is reduced to such a value that the heat produced by that current won't be able to maintain the arc, and thus the current is interrupted or the arc is extinguished. Okay, it's a simple method. Okay, simply the arc resistance is increased. As the arc resistance is increased with respect to time, the current density is current is reduced to such a value that that current won't be able to produce enough heat to maintain the arc, and hence what happens, arc will be interrupted or arc is extinguished. So because of the resistive nature of the arc discharge, most of the energy in the system will be dissipated within the circuit breaker. Okay, so the arc has resistive nature, I have already told you, I think. Okay, so arc is purely resistive in nature. The arc voltage and current will be in phase with each other. Okay, so because of the resistive nature of the arc discharge, most of the energy in the system will be dissipated within the circuit breaker. Therefore, while designing the circuit breaker, provision of mechanical strength to withstand such sudden release of large quantities of energy must be made. Okay, because energy is dissipated within the circuit breaker itself. Okay, so the circuit breaker contacts must have enough mechanical strength to withstand the sudden release of large quantity of energy. Okay, so Even though we are able to extinguish the arc by increasing the resistance of the arc, okay, but since the arc is of resistive nature, okay, so whatever discharge, whatever energy is dissipated within the circuit breaker, that energy must be means the circuit breaker must be able to withstand that energy. Okay, if it has sufficient mechanical strength, then only it will be able to withstand that energy. Otherwise, it will get damaged. Okay, so this is one of the drawback of this method. Okay, high resistance method for arc extinction. This is one of the drawback because of the resistive nature of the arc, the energy is dissipated within the circuit breaker itself. If circuit breaker doesn't have enough mechanical strength, then it will get damaged. Okay, so that is because of this drawback. This high resistance method is actually restricted to DC circuit breakers and air brake AC circuit breakers. What is air brake AC circuit breaker? In the next unit, classification of circuit breakers is there. So in that, in the next unit, we will discuss in detail about the construction and operation of air brake circuit breakers. So high resistance method, because of the drawback that it has. The drawback is what? It dissipates energy within the circuit breaker itself. Okay, so because of that drawback, it is restricted to DC circuit breakers and air brake type AC circuit breakers of relatively very low capacity of order of few 100 megavolt amperes. Okay, so now I have told you that in this high resistance method, we will increase the resistance of the circuit breaker to such a value that the current won't be able to produce sufficient heat to maintain the arc. Okay, so there must be some methods to increase the resistance of the arc. Okay, so let us see those methods. So the resistance of the arc, it can be increased. Okay, it can be increased by either by cooling the arc, okay, or either by increasing the length of the arc, okay, which is applicable only for low voltage systems, not for high voltage. I have already explained about it. And reducing the cross section of the arc, okay, by reducing the cross section of the arc or by using splitters. Okay, okay, so there are four methods are there to increase the resistance of the arc. One is cooling off by cooling method, by increasing the length, okay, by reducing the cross section, or by using splitters or splitting of arc. That's what I have written here. Okay, so splitting of arc. So let us discuss one by one. So cooling of the arc. Cooling of arc brings about recombination of deionized particles. You know, arc is nothing but arc. What is arc? Is made up of electrons, isn't it? Free electrons. Okay. So if by cooling method, if I am able to deionize the ionized particles, then the arc resistance can be increased. Okay, so cooling of arc brings recombination of the ionized particles. Okay, hence arc resistance will increase. Okay, the cooling will remove the heat of the arc, and the cooling is brought about by bringing the arc in contact with cool air. That's all. Okay, if cool air is blown into the circuit breaker contacts, okay, if cool air is allowed to flow into this circuit breaker contacts, when arc is struck between the contacts, okay, because of the cool air, ionized particles can be deionized and heat can be easily removed. Okay, next method is increasing the length of the arc. Okay, so arc length can be increased simply by increasing the gap length between the contacts. Okay, but increasing the gap length between the contacts is not practically possible for high voltage systems. Okay, but for low voltage systems, you can increase the length of the arc by simply increasing the distance between the contacts. Okay, so to draw the arc out to such a length that voltage available becomes insufficient to maintain the arc for low voltage systems. Okay, so the potential difference between the contacts won't be able to maintain the arc. Okay, so it will be insufficient to maintain the arc. For low voltage, it is applicable. This method is applicable. Okay, so next, reducing the cross section of the arc. So how to reduce the cross section of the arc? So one method is increasing the length of the arc, because whenever if you are able to increase the length of the arc, definitely cross section of the arc will be reduced. That is one method. Okay, so length of the arc has to be increased, means you have to increase the distance between the contacts. That is one method. Another method is, okay, you allow the arc to pass through a narrow passage. Okay, if you are able to allow the arc to pass through a narrow passage, then also what will happen? If the arc has to pass through a narrow passage, density of the electrons can be reduced, means cross section of the arc can be reduced. If you are able to do that, then arc can be reduced. Okay, so cross section of an arc can be reduced by having a small area of contacts. Okay, so small area of contacts means, so these two are contacts, isn't it? These two are the contacts, fixed contact and moving contacts. So assume these two are as are cubes, cuboidal structure. Okay, cubes. These two are cubes. So if these cubes are of very small cubes, these fixed and moving contacts are small cubes, then the contact area will be very small. Okay, so if the contact area of the circuit breaker contacts is very small, then the arc struck between these two contacts will have very small area, cross sectional area. Okay, that is one method. Another method, just now I told you, simply by allowing the arc to pass through a narrow opening, so that voltage won't be able to maintain the required potential. Okay, the voltage necessary to maintain the arc is increased. Okay, so when it is allowed to pass through a narrow passage, the potential difference won't be able to maintain the arc between the contacts. Okay, the one more method that is left over is by using splitters. Okay, splitting the arc. So where is it? Okay, where is this is the diagram. So splitting of the arc. Okay, so or the method that we are discussing now is the high resistance method, isn't it? So our aim is to increase the resistance of the arc. So resistance of the arc can be increased by splitting the arc into number of small arcs in series. Okay, so and each one of these arcs will experience the effect of lengthening and cooling. Okay, so see here, if you observe in this diagram, let us assume these are the contacts. Okay, so I will discuss about these arc runners and these splitters also we will discuss in classification of circuit breakers. Okay, at present our aim is we are discussing about the high resistance method, that's all. We concentrate on that. In detail, with more explanation, we will discuss about these splitters, arc runners in the air brake circuit breakers. Okay, in the next unit. Okay, so let us assume these two are the contacts. An arc is struck here. Okay, this is one contact. This is another one is fixed contact. Another one is the moving contact. Let us assume arc is struck here. Okay, this dotted line is the arc. Okay, now by some means, if you are able to move the arc upward, okay, you can do that by blowing air towards the arc. So if air is blown towards this arc will gradually move upward. Okay, all these dotted lines are the arcs. Okay, so arc is moving up. So what has happened here? The length of the arc is increased. Further, it is moved up. The length of the arc is increased. Further, it is moved up. The length of the arc is increased. Okay, so further it is moved up. Here you can see some rod type structures are there. Metallic rods are there here. Okay, so metallic rod type structures, you call them as splitters. Okay, so as soon as the arc reaches to these splitters, if you see, okay, this dark wavy shaped whatever you can see, this dark wavy shape is nothing but the arc. Okay, so the arc has entered into these splitters. Okay, you can see the length of the arc has increased to very large value. Okay, and it is split into some n number of arcs. Okay, you can have more diagrams here. So these are the splitters. Let us assume arc is struck here, this red line. Okay, you observe in this diagram, this red line is the arc. I hope you are able to see. This red line is the arc. Arc is struck between these two, and I have blown some air from bottom. The arc has moved upward, and as it has entered into the splitters. These are the splitters. So arc is divided into n number of sections. Okay, you can see this is there are two splitters here. Just for example, okay, arc is, see, at these edges. Okay, arc is bending. Okay, arc is bending, it has entered here. Again at the edges of the splitters, arc is bending. Okay, okay, so see, and because of the air that is blown towards this arc is traveling towards upward. Okay, it is traveling upward in between these two splitters. So what is happening? A weak link or weak point occurs at these edges. Okay, so arc will be split. See, you can see three sections. Okay, arc is split. So when arc is split, the contacts won't be able to maintain sufficient potential difference, and arc will be extinguished. Okay, you can see here in this diagram also, you can see only one splitter, one dark line. You can see, if you observe carefully, there is a dark line here. Okay, so this is our arc. This is our arc. There is a dark line here. You can't see in this first image. Okay, arc is forced to enter the splitters. Okay, you can see only one splitter here. Okay, in this diagram, if you are carefully observing the screen. Okay, only one splitter is there. Arc is forced to enter into the splitters by some external means, maybe due to blow of air. Okay, so it has entered, it is forced again, it is moving, and at last you can see the arc is split into two arcs here. Okay, so one is on one side of the splitter, another section is on another side of the splitter. Okay, so the resistance of the arc can be increased by splitting the arc into number of small arcs in series. Okay, number of small arcs in series. Okay, each one of these arcs, each one of these arcs will experience the effect of lengthening and cooling. Okay, I am blowing air into this, means definitely that air will take away the heat of this arc, and since it has been lengthened, definitely the density of the electrons has reduced in the arc. Okay, and this is one method. Another method is in between the contacts. Okay, so these are the rod like structures. Okay, so conducting plates, I can say. Okay, so in between the contacts, okay, in between these two contacts, I can place conducting plates. Okay, if I place conducting plates, then what will happen? Arc won't be able to directly move from one contact to another contact. It has to pass through each and every plate to reach the fixed contact from moving contact, if it is traveling from moving contact. Okay, so when it has to pass through each and every plate, then its length will be gradually increased. Okay, the length of the arc will be gradually increased. Okay, so in that way also we can split the arc. Okay, so this is high resistance arc interruption method. Next one is low resistance or current zero arc interruption method. Low resistance, or next method is what? Low resistance or current zero arc interruption method. So this method is applicable only for AC circuit breakers, because current zero interruption is not possible for DC. Okay, so in AC supply current, AC supply current will pass through the 0.100 times per second. It is observed that AC supply current will pass through 0 for, where is it? Yeah, the AC supply current will pass through. It is sinusoidal, isn't it? AC supply current is also sinusoidal. So AC supply current will pass through 0 approximately 100 times per second for the supply frequency of 50 hertz. Okay, the engineers what they have observed. Okay, so this property of this AC circuit is used for arc interruption purpose. Okay, so the current is not interrupted at any point, any other point. Okay, it can be interrupted at any point actually, but it is not interrupted at any other point except at current 0 point. Okay, except at current 0 point. If the arc is interrupted at any other point other than current 0 point, okay, it is observed that high transient voltages will occur across the contacts. Okay, so in order to avoid the high transient voltages which occur across the contacts because of the interruption of the arc at an instant which is other than current 0 anywhere, okay, any instant other than current 0, in order to avoid the high transient voltage, arc is interrupted at current 0 point. Okay, so this current, once it is interrupted at current 0, it is not allowed to raise again. Okay, so if it is allowed to raise again, then means the arc will restrike. Okay, so once the arc current is interrupted at current 0, it is not allowed to raise again. So, but in this method, the arc resistance is kept low. Arc resistance is not increased; it is kept low until the current is 0, where the arc extinguishes naturally and is prevented from restriking. Okay, after it has gone out at current 0. Okay, once it is extinguished, it is not allowed to restrike. Okay, so this method of arc extinction is employed in modern high power AC circuit breakers. Okay, now okay, there are two theories which will explain the arc extinction. Okay, arc extinction phenomena can be explained by two theories. I'll discuss those two theories in the next class. Okay, arc extinction phenomena can be explained by two theories. We'll discuss those two theories in the next class.